In this video, we'll take a look at how you can create 3D volumes from multiple 2D images in Niagara in Unreal 5.2. We'll also take a look at a new feature in Unreal 5.2 called Heterogeneous Volumes, which will allow volumes like smoke to have full lighting interaction without the need to link individual lights. If we take a look at this light here, point light pink, I'll be able to take this light and move it around, and you'll be able to see shadow and lighting interaction with this volume. And this all just happens automatically when this volume is a heterogeneous volume. I can also enable other lights like this point light blue, and that will also interact with the volume. So you can get interaction with your volumes with all your lights automatically using this feature. There's a couple downsides to this feature. If you have it turned on, your volume, like this cloud shape here, will not actually cast shadow onto other objects in the environment. But in most cases, that may not really matter. And again, these volumes are full 3D. To start making these volumes, I'm going to start with the empty scene and make sure the Niagara Fluids plugin is loaded. So under plugins, if you search fluid, make sure Niagara Fluids plugin is enabled and loaded. Once you have that done, you'll be able to right click, create a new Niagara system. I'm going to make an empty Niagara system and call it FXS for FX system and call it volume cloud. I'll open up that effects system and we'll have our empty Niagara system that we can start adding emitters to. I'm going to press E or right click and go to add emitter, and we're going to go under parent emitters and search for grid 3D base emitter. And I'll create a grid 3D base emitter. It'll have a lot of things here that it will create by default, which will just give us a solid volume. And I'm just going to collapse all these categories to make it a little bit easier to read and take a look at. Now, these volumes can get pretty heavy, so you have to be a little bit careful. If you want to add more detail, if you want to add less detail and make it run faster, you'll be able to modify how much voxels this volume is made up of by going to the emitter spawn section and setting the number of cells max axis. Right now, by default, it's 128, which is pretty much telling me that there's 128 voxels in all three axes. So 128 voxels going this way, and that way. So quite a bit of voxels, but in Unreal, it actually runs pretty quick. We'll leave it at default for now, but I just want to make sure everyone knows that's where you can change the quality or the resolution of this. If I put it down to 16, you can see it looks a lot more blocky and not as nice looking as it was at 128 voxels. Now our goal is going to be able to shape this volume by subtracting or controlling it with texture maps. So an example of this will be this. And this is what we're going to try to do. We're going to have our volume, we're going to minus a cutout or a shape from it and get a new volume with those details. Now we're going to be doing this with textures. So the very first thing we have to do is be able to set up a way that we can load in textures and control the density of these voxels or of this volume with those textures. So by default, if I go under the Init tab, we have a set emitter SimGrid density, which sets the density of these voxels. Are they solid? Are they empty? Are they semi-transparent? At 1, they're solid, 0, they're empty, 0.5, they're 50% full, and so on. You can control the opacity of those voxels with this controller. But this controller is controlling all the voxels on this kind of volume or on this kind of cube. What we want to be able to do is control individual voxels or subcomponents of this shape, like individual sections of the shape, by using a texture map to cut away and set that density as either empty, full, or semi-transparent. So to do this, we're going to click on the plus under Init here, and we're going to do a sample texture. We're going to sample a texture, and we're going to move that before we set our density, and we can plug in a texture here, but more importantly, it has UVs. What UV of this texture is being sampled for these the sample texture node for these voxels or whatever. And we don't want to sample 0, 0. We want to sample the correct space that will properly match our 2D texture to this 3D shape. So if we have a 2D texture here, we have to make sure that the texture gets projected properly on that shape. So it's not too small, not too big, not the wrong section of the texture. So we're going to have to set up a bit of a way to do that. So I'm going to take these two UVs here, X and Y, and break them so we can control each value individually and set up something a little bit more complex that will work with this. So I'm going to go here and click on that down and search break. That will suggest make vector 2D, which will pretty much break this out to X and Y control. Then what we're going to do is take that X and Y control, both of them, and turn it into 3 values, not just one value, but 3 values. And we'll be able to do that by clicking down and searching make float from vector. And we'll do that for both X and Y. Make float from vector. Now we have 3 values. Then we're going to multiply that. So multiply vector. So you get 2 values to multiply each other. Now the reason why we're doing this, and maybe it doesn't make much sense right now, but hopefully this helps out. The reason why we need to do this is we have this 3D volume. Let's pretend this cube here, that's simple, is that 3D volume. And let's just assume that it has 96 voxels in either direction. Currently we have 128, but let's just assume it's 96. When we project our texture, this here, it has to somehow fit that texture onto this voxel, and it won't know how. It won't know how to fit that texture onto these voxels. So we have to pretty much tell it the 0 coordinate of the UV. Won't matter how big our texture is in resolution, but it always uses the UVs of the texture. So we have to pretty much say the voxel 0 at the corner here will use UV 0, 0. And voxel down here, which would be 96 and 96 and 96 in all directions, needs to reference to UV1 or whatever UV coordinate it is. So we need a way of converting these voxel values to our texture coordinate values. For example, if we want to figure out what part of this 2D texture to draw on this point here, let's just say, well, that point's roughly halfway. So let's say it wouldn't be 96 voxels at that point. It'd be half that. So maybe something like 48 voxels. That's like voxel 48. So how can I tell voxel 48 to use the UV here, which would be 0.5? It's halfway in between that UV. I have to find out some sort of multiplier or some sort of conversion. And we can figure this out fairly easily by just dividing however many voxels it is on each axis. We're taking 1 and dividing it by however many voxels it is on each axis. So in this case, it would be like 1 divided by 96, and that will probably give me a value of like 0.0105 or something. So then if I want to figure out what here at voxel 48, right in the center here, what part of this 2D texture should it project on the center of this cube here? Well, that's halfway through the volume, or 48 voxels in. If I take 48 and times it by 0.0105 or something close enough, I get 0.5, so halfway through the UV. So that's kind of my conversion, 0.0105. Maybe we can have a bit more accurate, but that way, for each voxel into the shape, it will step that many UV coordinates into our texture and project the correct thing. So that's kind of what we're getting at and what we're trying to do with multiplying our 3D volumes coordinates to a factor that makes it line up with our 2D UV coordinates. Now, we don't actually have to do the math like I did there. We're going to do this the easier way, so we don't actually have to change that and modify it. It'll just kind of handle it for us. So once we have these set to multiply vector, the very first vector, so for x, for the a value, I'm going to get the grid 3D coordinate. So I'm going to search grid, and you'll see grid 3D unit coordinate. I'm going to use unit coordinates of the grid here, of this 3D grid, and I'm going to multiply that by something that's going to be able to properly set that multiplication value or set the value so it lines up with our UVs correctly. And I'm going to have to do this for both. So let's do this for both before we jump into that. Grid 3D unit coordinate for Y channel. I'll go to A as well and get the grid 3D unit coordinate. And this really gets messy and hard to look at, so it's going to be a little bit tough. But for the B values, what I'm going to end up doing is pretty much having a way of getting the maximum amount of voxels on each axis. That's what I'd like to get. So to do that, I could use something like world grid extents, which will give me the size of this box or volume. And I can use world cell size to get the individual cell or individual voxel sizes. And I can divide those by each other and get a value that would properly work for translating my 2D coordinates to this 3D coordinates. So that's kind of how we're going to handle it. I'm going to go to the B value. I'm just going to make it divide. So divide vector, and we're going to do that for both these, X and Y. So the B value will be a divide. And then in that divide for A, I'm going to get the cell size. So I can search cell size and get the grid 3D set resolution world cell size. And I'll do that for both on X and Y. So grid, search cell size. There it is, world cell size. And I'll divide that cell size by the grid extents. So I'll search grid extent. And you'll see this one here. Grid 3D set resolution world grid extents. And I'll do that again, both X and Y. And actually it says initial here. I'm going to make sure these match up just to be safe. Shouldn't matter really, but this one. Grid 3D set resolution world grid extents. And again, do that for Y as well. That's going to handle all of our coordinate conversion for this just to line up properly. So that's it. Now you also have channel. So X channel should be X. Y channel, should it be Y? Well, it depends where you want to project this texture. You have to look at the little coordinates down here and figure out what axis do you want to project the texture. Do you want to project it from this side? Then it's going to be Y and Z. If you want to project it from maybe this side, then it's going to be X and Z. X and Z. So we'll do that. So I'm going to set the X coordinate to X, the Y coordinate to Z, up and down. And it's going to project the texture like this on that face of the volume. So now that we set that up, I can actually add a texture in here. So I'm going to collapse this UVs. I'm going to throw in a texture to this. I'm just going to take something really simple that I have here, like this circle, and just pop it in there. And we don't see anything yet, because even though we've done most of the work now, we have to now take this texture, since we've sampled it, and feed it into our density. Now, if we want to set this volume to use the densities from this texture that we just sampled, we can now go to our density. Instead of setting it to just 1 or 0 or whatever, we're going to click on the down arrow and we're going to search sample. And now we can see our sample texture here. And we're going to sample the red values of that texture. And by sampling the red values, look at that. I'm now using that circular texture to cut away the density. Where the texture is white, it's values of 1 or solid. Where the texture is black or a low luminance value, it's setting the density to 0, which makes those volumes in those areas disappear. So now we've successfully cut out our texture in the shape, or cut out our volume in the shape of our texture, this little circle that gets projected right through it. Now, the lighting doesn't look good. It's lacking shadows, it's lacking lighting. So let's take a look at how we can fix that before we start making these shapes a bit more complicated. So to make the lighting better, what we're going to do is go to the mesh renderer down here, which renders these voxels. We're going to go in here. I'm just going to collapse all these because having everything open looks ridiculous most of the time. And I'm going to go to where it says rendering, and I'm going to turn on that feature, use heterogeneous volumes. And then what I'm going to do is you're not going to notice any difference because you have to have a certain material on your volume for this feature to work. So I'm going to go to override materials, and you'll see that by default, there's maybe like an M Raymarch smoke material in here. That's not the one that's going to work with this heterogeneous volume. So we're going to change it. We'll click on the little search icon, little magnifying glass here, and that's going to bring it up in your content browser. So if I minimize this, I'll go in my content browser. Now be very careful with this because this is part of the Unreal defaults and files. So you don't want to go modifying these because it will modify them pretty much forever if you end up saving them, and you won't be able to get the original thing back. So if you ever have to modify these things that are applied for Unreal water surfaces and things, go in here, find out what you need. In this case, it's the MI Heterogeneous Volumes Basic. And we're going to right click, duplicate so I don't break the original default. I'll call it basic underscore modified. And I'm going to move that to my own custom folder up here, just so it's not in the engine folders. I'm not breaking some part of the Unreal Engine that I can't get back. It might not let you move this. What you might have to do is save it first, then try moving it to your folder, and then it should move. So now I have that MI Heterogeneous Volumes Basic underscore modified. That way, if I mess this up, I'm not messing up one of the engine's default files. So now we're going to use that. So if I were to open up that material, it gives you a bunch of settings here, which we'll talk about. But that's pretty much it. I can put that into my volume now. So for our effect system, we want to put this heterogeneous volumes into the material. So I'm going to go here, mesh render. Instead of M Raymarch smoke, I'm going to put in my heterogeneous volumes basic. And then by adding that in, you're going to get a bit of an error saying voxel size not found on materials. You can ignore it. It's not going to be a big deal for this purpose today. But now you can see we actually get some better lighting on our volume. So how can we make this volume more complex? How can we make it more interesting? Well, that's what we're going to take a look at next. So now that we have our volume actually cut out, if you remember, we kind of projected that on the XZ axis, this kind of direction here. What if we go back to our sample texture and I duplicate it? So I'm going to duplicate that sample texture, and there's no duplicate here, but you can just click on it and go Control C, Control V. There you go. It makes the sample texture 001. One thing that turns on for some reason when you copy and paste this is this generate UV using importance sampling. That might cause problems with what we're doing, and it might not sample values correctly. So we're going to turn that off. Just make sure you turn that off if you do copy and paste it. But now in the sample texture 001, we're also going to project a texture, maybe a different one, but to a different axis. We've already projected a texture like this. That's of a circle. Now we're going to project a texture like this that maybe has a different cutout or a different shape. So how can we do that? Well, if we want to project on this axis, if we look down here, it's Y and Z. So I can go in here and make X, Y, and make Y, Z. Now that won't make a difference yet because we haven't used the sample texture 001. But I'm going to go to density now. And instead of just sampling this texture, I'm going to reset this. I'm going to click on the down arrow. And maybe what I'll do is some sort of math operation. You could divide, you could multiply, you could do all kinds of things. I'm going to do a subtract. And I'm going to take my A value, which will be our sample texture, red channel, and minus the sample texture 1 red channel, the texture being projected on the other axis. And now it cuts that shape into itself. So now we're projecting a circle in this direction and then projecting a circle that's minusing away in that direction. So we can start to produce more complex shapes doing this. For example, if I go back and change those textures, so let me just resize this window a bit to make it easier to deal with. I can maybe set the first texture to be this cutout. That's pretty cool. And the second texture to be this cutout. And now I get this 3D box of this Unreal logo. Now it may be flipped upside down. So if I want to flip that around, I can just go to the texture where I'm sampling that. UVs are probably just flipped. So instead of X and let's make this easier to look at, instead of X and Z, I can make it Z and X, or different coordinates. And you might have to also kind of rotate it in your scene to get the angle that you want. But you can play around with these to project on different angles. Like if I want to project from the top, it's going to be X and Y. So I could set this to X and Y, and now it's projecting from the top. And if I want to cut a circle through the side or something, well then on Y and Z, here, Y and Z, I can use the circle and cut a circle out of it. Now, if it looks too solid, like right now it's really harsh shadowing, that's going to have to do with our material. So I can pop this into my scene now, this volume that I just created, and move it. And there it is. And it looks a bit solid. So I can go into the material that we're using for this and start changing some settings. I could make the albedo, which is the color, leave that at 1. But I can turn a bunch of these things off. I don't need a lot of these. I can reset some of them. The one that I want to change is density gain. You lower that, makes it lower density. Now it feels more like a cloud. If I rotate this, let's turn on snapping here. Now it feels more like a cloud. And you can modify this and change it. So density gain, make it more dense, less dense. We have constant extinction. Give you a way to kind of contrast these values a bit. You have density offset. You can cut away from them a bit more. But you'll be able to play around with this. But first, you probably want to get a more complex pattern. Now, we're only projecting on the front axis and side axis to cut away or to shape these things. You can also project on the top-down axis, all 3 axes, and create much more complex shapes. By projecting on all 3 axes, I can start creating things like this cloud puff here. And with that material, if it's utilizing that heterogeneous based material, I'll be able to have lights that properly interact with it. So if I create a point light and just go in here and change the color, red or something, it will properly interact with that volume. Now, if you want to make sure you get shadows on the volume from this light as well, just make sure that in this light, that when you scroll down, that you have your cast volumetric shadow enabled. If you don't have that, you won't get shadows from this light. But if I enable that, then I'm going to make sure I get shadows on that cloud volume as well. Let's maybe turn off my directional light just so we can see this. But now we make sure we get shadows on that volume. And if I add more lights, I duplicate this light, make it a different color, maybe blue, green, whatever. Bring its intensity down a bit, bring both these intensities down a bit, you kind of see these lights interacting with our volume. So really cool, really easy to set up and fun to play with. This is probably a pretty quick way to create some 3D volumes. You can do this a lot of other ways through materials, but this way is going to give you good interaction with your lighting and fairly easily to set up. It didn't take that long for us to create this, whereas writing a custom shader to make this cloud, it's going to be a little bit more work, because Unreal kind of has ways of doing the same thing, but through their effect system or through a different route that may be a little bit easier. One last tip for if you're working with these volumes is you might be struggling to figure out how you can divide, multiply, subtract these different textures together to produce the shapes that you want. One useful thing is this other mesh render here. If you turn that on, it'll give you a card cutout showing you what's being written into your density parameter or into your density grid. So you can kind of take this second mesh render, turn that on, and adjust this MI debug volume slice and move that slice around, change its axis, and just inspect what values you have in your density. And that's very useful for producing these volumes. But you can find more tips like that if you're part of the Patreon, which you can check in the description below. And you'll get access, if you're part of the Patreon, to the PDF for this video that goes over a couple extra things in a bit more detail. But if you enjoyed this video, make sure to like, subscribe, press the bell icon to be notified of future videos, and let me know what you'd like to see for upcoming content. And just a scroll through on this PDF that the Patreons get. It's pretty long and extensive. It goes over all the steps we saw in this video today, but also has some better ways of explaining things with some diagrams as well. So it makes it a bit easier to understand if you want to review this stuff or jump back to it in the future at some point.